Welcome to today's lecture. Myself, Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The subject that I am covering in my lecture series is microprocessor. Code is KCS 403. Today I will cover the instruction set of 8085. Since 8085 is 8-bit device, we all know that it's 8-bit device, so it can have up to these many instructions, but it only uses 246 combinations that represent a total of 74 instructions. So today we will briefly see all these instructions. We will understand what these instructions perform. So when we talk about any instruction, it has two parts. First part is the task or operation to be performed. This part is called the opcode or operation code. Second part is the data to be operated on, that is known as the operand. So these are two important terms which are the integral part of any instruction, that is opcode and operand. When we talk about instruction size, as I have already discussed in the previous lecture, that instruction format specifies the instruction size. It can be 1 byte, it can be 2 type, or it can be 2 bytes, or it can be 3 bytes instruction. 8085 instruction set can be classified into 5 types, that is data transfer instructions, arithmetic instructions, logical instructions, branching instructions, and machine control instructions. So in this lecture we will see some of the these types, and in another subsequent lecture we will discuss another types. So when we talk about data transfer instructions, the very basic instruction is move, and it has the following combinations of operands. It can have 2 registers in the operand, it can have 1 memory, indirect memory pointer or register in as the operands, or it can have the destination in the register in the destination and the memory pointer in the source. So these are the possible combinations for this instruction. So what is basically this instruction doing? This instruction is copying the contents of this destination into the contents of this, the copying the contents of the source in the location of destination. For example, move B comma C, it will copy the contents of C into B. Move B comma M, it will copy the contents pointed to by the HL register pair, that is because M specifies the pointer given by HL register pair, and it will copy that contents into B register. So this instruction is related to the immediate addressing mode. I have already discussed in my previous lecture, and the combinations present in this is obviously here will be immediate data in the source operand, and in the destination operand it can be register or it can be the memory pointer. So if I write MVI B comma 57, so 57, this immediate data will be copied to B, and if I write MVI M comma 57, so this immediate content will be copied to memory location pointed to by HL register pair. LDA 16-bit address, it means it will load the accumulator with the 16-bit address, that is it will load the accumulator with the contents at 16-bit address. For example, LDA 20304, it should be here, okay. So LDA, this is LDA 2034H, it will copy the contents present at this memory location into A. This is not the content which is being directly copied to A. Please note it, because this here is this is not immediate addressing mode. This is the direct addressing mode. This is the address, and the contents present at this address will be loaded into accumulator. So LDA, load the accumulator. LDAX, it means here X denotes the register pair, the presence of register pair in the operand. LDA means load the accumulator. Now accumulator is 8-bit, register pair is 16-bit. So how the contents of register pair will be copied to accumulator? No, this is not happening in this instruction. In this instruction, the contents of the memory location pointed to by the register pair mentioned in the operand, the contents of that memory location is being loaded into accumulator. So what is this instruction doing? Suppose B, C, because with B always the combination is of C. So suppose BC contains 2034H. Yes, in B it is 20, in C it is 34. Now this is some memory location, and this memory location, suppose 02. This is the data which is present at this memory location. So after the execution of this instruction LDAXB, then what will happen? This 2 will be loaded into accumulator. So it will load the accumulator with the memory the contents of the memory location pointed to by this register pair which is mentioned in the operand. ST, that is store the value of the accumulator into the register into the address mentioned in the operand. So the contents of the accumulator will be stored from here at this address location. So in this example, the suppose the contents before the execution of this instruction, the contents of the accumulator are 41. So now after the execution of this instruction, the contents of the memory location 2500H will be 41. So this is what is happening in this instruction. STAX, it will again store the contents of the accumulator where? At the memory location pointed to by this register pair. So this is just the opposite of LDAX. So after writing the STAXB, it means it will store the contents of accumulator into the memory address that is pointed to by the BC register pair. Suppose it is carrying this, it is storing 20434. Now, so this is the memory location, and at this memory location the contents of accumulator will be stored. Another interesting instruction under this category, that is data transfer instruction, that is the SHLD, that is store the HL register pair directly into the 16-bit address mentioned here. It means the contents of the register L are stored to the memory location specified by the 16-bit address, and the contents of H will be stored at the memory location above this above this address. Suppose I am writing this. So what will happen? So the contents of L will go to will be stored at this memory location, and the contents of H will be stored at 2551 memory location. So in this way, the lower order register contents will be copied to the lower order address, and higher order register contents will be copied to one higher address. Exchange, it will exchange the contents of HL with DE register pair. So the contents of H are exchanged with D, and the contents of L are exchanged with lower order address, that is the E. So H, L exchanged with, in this way we can understand, HL exchanged with DE, H with D and L with E. So this is what is happening using this instruction, that is exchange, XCHG. Now again SPHL, that is it will load the contents of HL pair into stack pointer, HL pair into stack pointer. So it will copy directly the contents. Suppose HL contains 2045. So stack pointer at the very next moment after the execution of this instruction will store this. XTHL, that is the exchange the contents of the top of stack, T stands for top of stack here, with the HL register pair. The contents of L register exchanged with the location pointed to by the contents of stack pointer, and the contents of H register are exchanged with the next memory location, that is stack pointer plus 1. So in this way it will exchange the contents of the top of stack with HL register pair. So obviously the top of stack is pointed to by stack pointer. So the contents which are pointed to by stack pointer will be exchanged with the L, and another higher address, that is the stack pointer plus 1. The contents of this memory location will be exchanged with the higher order address, that is H. So in this way the contents of the both will be exchanged. PCHL, that will exchange, it will load the contents of HL, that is it will basically copy the contents of HL into program counter. So contents of H are placed at the higher order byte, and the contents of L, because it is a lower order address, it will lower order register, so the contents of L will be stored at the lower order byte. PCHL, it will copy the contents of HL register pair into program counter. Now after this instruction, next instruction is push, and very next is pop. So both push and pop works with the stack. So what is push doing? Push will copy the contents into the stack. It will load the stack with some contents. So it is known as a push operation. The contents of register pair are copied onto stack. Which register pair? The mentioned in the operand. So the contents of this register pair will be pushed onto the stack. Since we know that when we push something into the stack, the address of the stack, that is the top of the stack, that is the stack pointer which is holding that address, it goes in the opposite direction. Means suppose this is the stack, and if it is filled here, okay, so here up to here it is filled. So the contents of the stack pointer goes in the opposite direction. Means if this is 2005, then it will be 2004, it will be 2003, and it will be 2002 and 2001 and so on. So whenever we push something into the stack pointer is decremented, we can see here. So in this way the stack, the addresses of the stack, that is the stack pointer, the contents of a stack pointer goes into the opposite direction when we push something into it. So while pushing something into the stack, while copying something into the stack pointer is decremented, and the contents of higher order registers, that is either the B, D, H and A, these are all higher order registers, these are copied onto stack, and stack pointer is again decremented because again the content has to be loaded, then contents of lower order registers have to be put into it. So whenever if we write push B, means BC here, yes, but we don't write C here, we just write push B. It already means that we are pushing the contents of BC register pair into a stack pointer. So what will happen? Suppose we are at this location 2002, then a stack pointer will be decremented by 1, so it will go to 2001. The contents of C will be loaded into 2001, and again the stack pointer will be decremented and it will go to 2002, and now the contents of B will be copied to it will be decremented 200. So it will 2000. So in this way, as we go up, as we push something into the stack pointer gets decremented, and the contents of lower order is first stored, and then the contents of higher order is first stored. Yes, oh, I told you the wrong thing. When the stack pointer is decremented once, the content of higher order is stored here, and when it is decremented again, since this address is lower than the this one, so the contents of lower order address will be stored here. So first higher order and then lower order. So this is always the sequence when storing something into the stack. And this is the pop is just the opposite of push. So whenever we take out something from the stack, that is known as the pop operation, and whatever will be popped out of the stack, it will go into the register pair, and again the sequence is same. Suppose the stack is filled above till here, Okay. So this is again, this was 2004, this was 2003, 2002 and 2001. So this is the sequence. If we are popping something from here and we are writing pop H, so again HL register pair will be considered. Since this address is lower, so the contents of this will go into L. Yes, and since this address is higher, then again the contents of this memory location will be popped to L. Stack pointer will be incremented by 1. Stack pointer now comes to 2002. The contents of this will be copied to H. It will be popped into H, and again the stack pointer will be incremented and will go to 2003. In this way, the sequence is used here. Now we come to out operation. The contents of accumulator are copied into the input output port. So using this, the whatever is into the accumulator is copied to this port address. This is the out operation. It always works with the input output ports and the accumulator is involved. So whatever the contents are stored in the accumulator, that will be out to the output port. This is the address of the output port. When we talk about the in operation, in instruction, so whatever the contents are available at the port given by this port address here, so that the contents of that port address will be copied to the accumulator. It will be taken into the accumulator. So now we come to the arithmetic instructions. In the arithmetic instructions, add operation is a very common one, and using this add operation, by default one operand is always the accumulator. So here another operands may be register or the pointer denoted by M. So by writing add B, it means the contents of B are added with the accumulator and the result will go to accumulator, and similar is the case with this. ADC, it means the addition is being performed along with the carry. This instruction denotes accumulator, addition of B plus accumulator plus carry, that is the carry flag. So in this way, this is not the register, but this is the what I am denoting is carry flag, and the result will go into accumulator. ADI, it is the immediate addressing mode, and here the whatever is mentioned in the instruction, it will be directly copied to accumulator, that is A plus 45H, and it will be result will go into accumulator. ACI, ACI means it is again the immediate addressing mode. Whatever the contents are written here in the instruction, the accumulator, they will be added to accumulator along with the carry, and the result will go into accumulator. DAD, that is the decimal adjust, that is a double addition. DAD means double addition, that is the 16-bit contents of register pair. Whatever register pair is mentioned here, they are added to the HL register pair, and the result will go into HL register pair again. So DAD, that is a double addition. Here DAD-B, it means BC register pair contents are added to HL register pair contents, and the result will go into HL register pair. Now the subtraction. In the subtraction, the whatever operand is present here, it will be subtracted from the accumulator. SUB is the instruction. Here SUBB means the contents of B will be subtracted from the accumulator and the result will go into accumulator, and similar is the case with this indirect addressing mode. SBB means here that the contents specified by this operand are subtracted from the accumulator along with the borrow, that is along with the carry. So what will happen is accumulator minus B minus carry flag, that is known as a borrow in the case of subtraction, and the result will go into accumulator. SUI, it is the immediate addressing mode. The contents specified here will be subtracted from accumulator and result will go into accumulator. SBI, the contents specified here will be immediately, that is the immediate content, this is the immediate addressing mode, the contents will be subtracted from accumulator along with the borrow, that is known as the carry, and the that the result will go into accumulate. Increment or decrement instruction, that is the contents whatever they mentioned in the operand, the contents of that operand are incremented by or decremented by 1. So this is for increment INR R or M, these are the combinations which are possible, and writing this instruction it will increase the contents by 1. INX H, it will increase the contents of register pair mentioned here, because this X denotes the register pair. So writing INX H means here the H is for HL register pair, it will increase the contents of HL register pair by 1. DCR, again for decrement operation, it will decrease the contents of B or the contents of the memory location pointed to by M by 1. DCX, it will decrease the contents of HL register pair by 1. This is an example, it can be any register pair here. So that's all for the instruction set, that is the data transfer instructions and arithmetic instructions. In next lecture, I will tell you about other instruction sets. Thank you.